Hello, welcome to today's lesson. So, in today's lesson, we'll be looking at the chain rule, a fundamental rule in differentiation. Okay, the chain rule allows us to differentiate composite functions very easy. When you say composite functions, it simply means a function that is contained in another function. Okay, or a function inside another function. Okay, so that's a composite function. So let's quickly dive in it. So if f and g are both differentiable and capital F, which is equal to f composition g, is the composite function defined by capital F of x, which is equal to f of g of x, then f is differentiable. So what this means is that if we have f and g, which are both differentiable, okay, then their composition is also differentiable. Okay, so their composition, f composition g, which is defined by f of g of x, is differentiable. Okay, and if we are saying that f of g of x is differentiable, then it implies that f of x is what? Differentiable. So that is what it is saying. Okay, now from f of x, which is equal to f of g of x, okay, if we let y be is equal to f of x, then you're going to get y is equal to f of g of x. You get it? Okay. Now, if we let u be equal to g of x, then this implies that our y is equal to f of u. Hope you get it. So, when you come here, if we let y be equal to f of u, and we let u be equal to g of x, then according to the chain rule, our dy dx will be dy du multiplying du dx. Do you get it? So let me explain. So we said that our u is what? G of x, and our y is f of u. Okay, so according to the chain rule, for you to get the y dx, then you have to differentiate this y with respect to the u. Okay, so the y du multiplying you differentiate this u with respect to what? The x. So du dx. Do you get it? So that's basically the chain rule. Okay. So let's take an example. We are to find f prime of x if f of x is equal to the square root of 1 plus x squared. Okay. So let's solve it. Okay, so you have been given f of x to be root of 1 plus x squared. So here, let y be equal to f of x. Okay, which implies that our y is equal to what? Root of 1 plus x squared. Okay, and let u be equal to 1 plus x squared. Okay, which implies that our y is equal to what? Root of u. Mm. So we have y equal to root of u, and we have u is equal to 1 plus what? x squared. Okay, so here we can write y to be u exponent 1 over 2. Okay, so we can see that this is a composite function because we can see it as one function inside another function. Do you get it? So we have the inner function 1 plus x squared, okay, which is the u, and the outer function root of u, or u exponent 1 over 2. Do you get it? So that's why we can apply the chain rule. So in applying the chain rule, we are having here y to be u exponent 1 over 2, and you have our u to be 1 plus s squared. Okay, so you have to find the y du, then we find du dx. Okay, so our dy du is equal to 1 over 2 u exponent 1 over 2 minus 1, which is negative 1 over 2. Okay, and du dx is equal to 2x. You get it? Because when you differentiate a constant, you get 0. So when you differentiate 1, you get 0. And when you differentiate x squared, you get 2x. Okay. Now, according to the chain rule, we are going to get our dy dx, to be dy du times du dx. Okay. So you're going to get 1 over 2 u exponent negative 1 over 2 multiplying 2x. So here these two cancel these two. So you are going to get x u exponent negative 1 over 2, which is same as x over root of u. But we said that our u is what? Our u is 1 plus x squared. Okay. So we are having our dy dx to be equal to x over root of 1 plus what? S squared. So this is our final answer. Okay. So let's take another example. We have to differentiate y is equal to sine x squared. Okay. So here too, we are going to use the chain rule because it is a composite function. Okay. So we let u be equal to x squared. Okay. Which implies that our y is equal to sine what? Sine of u. Okay. So you have our inner function to be what? X squared. And our outer function to be what? Sine u. Okay. So we find du dx, which is what? 2x. Do you get it? Then our dy du will be, so we learned that when you differentiate sine x, you're going to get cos x. Okay. So here too, when you differentiate sine u, you're going to get what? Cos u. Okay. So according to chain rule, we have our dy dx to be equal to dy du multiplying du dx. Okay. And our dy du is cos u multiplying our du dx is what? 2x. Do you get it? So here you're going to get 2x cos what? Cos u. But we said that our u is equal to what? X squared. So we'll do substitution here. So you're going to get 2x cos x squared. So this is our final answer. Okay. Thank you very much.